Our first topic in section 2.6 will be on domains of functions. If you look on page 299 of your textbook, you'll see some introductory concepts where we start to look at how we express the domain of functions. Now, if a function does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of the function f of x is a real number. So, just to introduce this concept, you can think of the domain of all real numbers in interval notation represented like this. These would be all possible values of x from minus infinity to infinity. So we start with this domain of all real numbers minus infinity to infinity, and then we might have to exclude real numbers based on two criteria, or things that we're looking for. One, any value that causes division by 0. And then two, any value that would cause a negative square root. Those are the two issues we need to be on the lookout for when we're looking at the domains of functions. So your text gives a couple examples to introduce this concept. One function they have is 1 over x minus 3. Now notice we have a denominator here, and if we set x minus 3 equal to 0, well, we would identify that when x has the value of 3, it will cause division by 0. So initially we can say x cannot equal 3, but we really need to express that in interval notation. So we start with all real numbers, and then we need to exclude this value. So in domain interval notation, it will look like this. We'll of course have minus infinity, infinity, but we really have two intervals of valid values. And so notice here, 3 is the excluded values, and this is very important. Notice the parentheses here. That means that value is strict, right? That value is not included in the interval, right? These symbols cannot be brackets. Otherwise, you'd have a value of 3 in your domain, which would cause division by 0. So again, start with minus infinity to infinity, see what values you have to exclude. And this symbol here just means union. It's just joining these two intervals of real numbers. So this is an example when we have to exclude a value because it causes division by 0. Your textbook then shows another function with a square root. And when we determine that domain, one thing that can be helpful with your square root problems is think about what value would just give you exactly 0. So in that case, that would be x equals 3. And then you want to think, well, would values greater than that value or less than that value cause negative values? So notice, if x is less than 3, say 2 minus 3 would be negative. That would be an invalid value. If x is greater than 3, well, like 4, well, 4 minus 3 is 1. That's positive. That's fine. So in this case, x has to be greater than or equal to 3. Remember, 3 minus 3 equals 0 is fine. Square root of 0 is 0. That's still a real number. So in interval notation, it would be this. And notice, because of the greater than or equal symbol, we have a bracket here for our interval notation. Let's look at example 1, which is on page 299 of your textbook. So they give us 4 different functions. We'll look at each one individually. So part A is x squared minus 7x. Now remember, the two things we need to be concerned about are division values that cause division by 0 and negative square roots. If you look at this function, we don't see either of those. There's no denominator and there's no square roots in this function. So in this case, the domain, and I'll just abbreviate here with capital D, the domain is going to be all real numbers. No values would be excluded, right? We can substitute any real value of x into this expression. We won't get division by 0 or a negative square root. Now in part B, notice we do have a denominator. So what you really want to do here is factor that denominator. And if you do that, you'll have x minus 3 times x plus 1. And now what values would make these factors equal to 0, which would cause division by 0? Well, in this case, x cannot equal -1 or 3. Now, when we express that domain in interval notation, remember, we start with all real numbers minus infinity to infinity, and then we have to exclude the values of -1 and 3. And notice those values go in ascending order, right? Notice that -1, of course, is going to come before -3. And I'll use the union symbol to join those different segments. Again, these symbols next to -1 and 3 must be parentheses. They cannot be brackets. Okay, let's look at part C. Now, here we don't have any denominator, no division by 0, but we have a square root. So again, one thing to keep in mind is, what value might make this expression 0? That's always a good starting point. So notice, if x equals -4, then that expression would be exactly 0. Now, if we think of smaller values, say x is -5, well, that'd be -15 plus 12, that would be negative. And if we have a smaller value, like -3, well, that'd be -9 plus 12 is a positive 3, that would be a positive value. So in this case, we know that the values have to be greater than or equal to -4. And again, because of the greater than or equal symbol, I will have -4 to infinity, and I'm going to use the bracket here. So let me just highlight these solutions. And so there's some good first 3 examples in example 1 to show you when sometimes there are no exclusions with real numbers, and then a good example of division by 0 and a negative square root. Let's look at part D. This is a little bit trickier example, but I'll step through it. So notice we have a denominator, and the denominator has a square root. So we really need to keep in mind that we can have division by 0 and negative square roots. So let's look at them one at a time. For the division by 0, if we think about that concern, well, x cannot equal 7, correct? If we substitute 7 into the denominator here, well, we'll get 14 minus 14, the square root of 0. That would be fine for the square root, but would cause division by 0. So x cannot equal 7, and we also cannot have any negative square roots. So when we think about that, x equals 7 is that key value. Now, if x is less than 7, say 6, we'd get 14 minus 12. That would be a positive value. If x is larger than 7, like 8, we get 14 minus 16, that's minus 2. That's a negative. So in this case, x has to be less than or equal to 7. Now, when we put together these two items in the domain, it's going to look like this. It's going to be minus infinity to 7, but we have to use a parenthesis here. Notice if it was just the negative square root, the less than or equal to symbol, we could have a bracket here. But notice we have to exclude the actual value of 7. So that bracket needs to be a parenthesis. So part D, probably one of the trickier examples you'd see with domains of functions, where they really combine the two issues that we have to look out for. Now, for a little extra practice, work on the 2.6 pencil problems, 1A and 1B.